Hello everyone, I'm Jacob Kaufman, I'm the nerd on the street, and today we're getting started with LVM. Okay everyone, LVM stands for Logical Volume Management, and it's basically an abstraction layer to help you manage your storage devices. With LVM, you can take many different hard drives or SSDs and combine them into pools called volume groups. Then you can use those volume groups to create virtual devices called logical volumes. Why would you want to do that? Well, maybe you've got some large files or a large number of files and you want to keep them all in the same place logically, but maybe none of your physical storage devices are large enough to hold all of that information. With LVM, you can combine those different physical volumes into one virtual volume very easily. LVM also has other uses. It can do mirroring, striping, basically any RAID configuration. It can even do snapshotting, and along with other tools like Lux, it can also be part of an encryption solution. Now, there are lots of cool storage technologies out there today. There are file systems like ZFS and BetterFS, and there are also other abstraction layers such as VDO that can do kind of the same thing as LVM and combining different disks together. But the big advantage with LVM is that it's part of the Linux kernel, so no matter what Linux distribution you're using, if it's Red Hat or Fedora, Debian or Ubuntu, not only will the same management commands and concepts work on any of those distributions, but you can even move your LVM volumes between different computers, different servers, even if they're running different Linux distributions, and they will all detect LVM devices properly. Now, this video is going to build on top of a previous video I did, which is my disk management video in my Bash Basics series. In that video, I talked about managing physical partitions on the command line using tools like fdisk, gdisk, and parted. And this video is not in the Bash Basics series because LVM is a little bit more of an advanced concept, but if you're not already familiar with managing partitions on the command line in Linux, I would go and watch that video first. Then this video is going to introduce you to some basic LVM concepts and very simple usage, and then I might make some follow-up videos in the future covering more advanced LVM topics. For this video, we're just going to keep it very simple. We're going to take 3 physical hard drives and we're going to add them all to a single volume group so that we can create a single logical volume out of them. That way, all 3 hard drives will show up as a single device to the computer, allowing us to store larger files than we would otherwise be able to. I think that's pretty much all the introduction we need here, so without further ado, let's cut to the desktop and get started. And here we are on the desktop. I'm going to start by opening up a terminal that we're going to use. And I'm also going to open up gparted just so that we can keep an eye on what we're doing graphically. So we'll just have that off on the side of our screen. And before we start running any commands here, pretty much all of the LVM management commands, even the ones just to view information, we're going to need root privileges for. So instead of typing sudo at the beginning of every single command, I'm just going to type sudo-i to enter an interactive prompt as root. Now over here in gparted, we can see the disks that we're using here. In this video, we're going to be using dev SDC, SDD, and SDE. These are 3 50GB disks on our system here, and as you can see, all 3 of them are currently entirely empty. So in order to use these disks with LVM, I first have to format them as LVM physical volumes. Once we have our physical volumes formatted, we can add them all to a volume group, which is sort of a big pool of space that we can then logically assign to our logical volumes. So creating a physical volume or formatting a physical volume is very simple. We're just going to run pv create and then the path to the disk or device that we want to format. Now this can be either an entire disk or it can be a partition. For the first example, I'm going to run this directly on dev SDC. This is going to format the entire dev SDC disk as an LVM physical volume. So I'll run that and you'll see it pretty much immediately says physical volume dev SDC successfully created. If I come back over to gparted and refresh here, you can see this is now formatted as an LVM2 physical volume. The other way that we're going to demonstrate with dev SDD is creating a partition on the disk first and then formatting the partition as an LVM physical volume. If you want to go that route, we will first use a tool like gdisk to create our partition. So we'll run gdisk on dev SDD. Since the disk is blank, I'll just hit O to create a new partition table. Even though it would have done that automatically for me anyway, I just like to do it manually. Next, we'll hit N to create a new partition, just like we talked about in my Bash Basics video for disk management. However, for the hex code down here, for the type of partition that we're creating, I'm going to enter 8E00. If you're using fdisk instead of gdisk, the partition type would be just 8E, but here in gdisk, it's 8E00. So I'll hit enter, and you can see gdisk recognized that partition type as Linux LVM. So now I'm going to hit W to write my changes. I'll confirm with Y. And after just a moment, the operation is completed successfully. Now, if we come down to our dev SDD disk here and we refresh gparted, you'll see we have a partition here on the disk. The name is Linux LVM and the flags say LVM, but the file system type right now is unknown because even though we've created that partition, we haven't actually formatted it as a physical volume yet. To do that, we'll run the same command we ran before. That's pvcreate dev sdd1. And after we run that, if we refresh one more time, you can see gparted will now recognize this as an LVM2 physical volume. Now, why would you do one of these things over the other? Comparing our SDC disk here with our SDD disk, well, you can see that SDD has a couple of things that SDC does not. It does have a name applied to it, Linux LVM, and it also has the LVM flag on the partition there. SDC, since there is no partition and there's no partition table, there's nowhere to put that metadata. There's nowhere to put flags. LVM has its metadata on that disk, and gparted is smart enough to read that LVM metadata and know that this is a physical volume. However, it's generally recommended that you go ahead and create a partition. Even if you're using an entire disk for LVM, just create a single partition on the whole disk and format that partition as your physical volume, because other operating systems like Windows or Mac OS that might not be prepared to read an LVM physical volume, when they look at dev SDC, they won't see a partition table, and so they might just think that disk is unformatted. They might show it as available space and offer to create a new partition table, which would wipe your data. Whereas with SDD, since this is a partition, even if another operating system like Windows doesn't know what type of partition this is, even if it doesn't recognize LVM physical volumes, it will still at least recognize there is a partition table here and there is a partition taking up the entire disk. So from an administrative point of view, you have less of a chance of accidentally overwriting data thinking that this disk isn't formatted in a different system. So for our example here, I'm using one disk of each method just for demonstration purposes, but normally you would want them to match, and the partition method here is the way to go. So now we have two physical volumes. Like I said, the next step is to create a volume group that is going to pool these volumes together into space that we can use. For that, we're going to run vgcreate, the name of the volume group, and I'm just going to call it my volume group. And then we just list all of the physical volumes that we want to put into this volume group. So the first physical volume is dev SDC, and the next physical volume is dev SDD1. So once again, whether you used entire disks or partitions, make sure that you specify them appropriately when creating your volume group. If you do create a volume group with a device that has not been formatted as a physical volume yet, vgcreate will actually create the physical volumes for you, but it's a good idea to not get in the habit of that. You don't want to accidentally wipe a volume that you weren't intending to because you were taking a shortcut. You want to consciously know which volumes you're using. So just go ahead and create the physical volumes first and then put them in the volume group. So I'll run this, and it says volume group, my volume group successfully created. If I come back over to gparted and I refresh on dev SDD here, you see we now have a mount point. Now this partition isn't really mounted. We can't use that space, or we can't access anything in there right now. But gparted recognizes that we have a quote unquote mount point of my volume group because we're never going to access this LVM physical volume directly. We're only going to be accessing a logical volume later. So as far as gparted's concerned, the fact that it's part of a volume group, that's as far as gparted's going to be able to see in terms of what it's being used for. And you can see that SDC is also part of that same mount point. With regular partitions, you can't typically have two partitions mounted at the same mount point at the same time, but since this is LVM, both of these physical volumes are part of the same volume group. Finally, we need to create a logical volume, and that's going to allow us to actually access that space. To create the logical volume, we're going to run lvcreate. We'll specify the name of the volume group that this logical volume will be part of, so that will be my volume group. Next, we want to give a name to the logical volume itself, and for that we'll use the -n parameter for name. We'll just call the volume my volume. And finally, we specify the size. Now we can either specify the size in physical extent, which I'll talk about in a little bit more detail in just a moment, but that's basically chunks of data. It's the smallest addressable amount of space that we can assign out of our volume group. Or we can specify the space in regular old units that we're used to, like megabytes or gigabytes. We're going to do that, and we're going to use capital L to specify a real size for this logical volume. Now we have two 50 gigabyte disks here, and you can see that gparted recognizes them as 50.00 gigabytes since it's GIB. So I'm going to try specify 100 gigabytes right here, and I'll hit enter, and you'll see we have insufficient free space to actually do that. You see we're only missing 2 extents, 1 extent per device, so this would be metadata taking up space on those disks. That's LVM metadata taking up a very small amount of space, only one little block, 1 extent on each physical volume. But we don't quite have enough space to assign the entire 100 gigabytes to a logical volume. We cannot over provision a logical volume. So instead of 100 gigabytes, for now I'm just going to go down to 99 gigabytes. I'll hit enter, and you see logical volume, my volume created. So at this point we have a logical volume, and if we come back over to gparted and refresh here, let's go to dev SDC. If we refresh dev SDC, you can see the used space has gone all the way up. It's 100% used. All 50 gigabytes have been assigned to a logical volume. Now, if we come down to our dev SDD partition, you can see it's not quite 100% used. Like I said, we were only 1 extent per disk short of the full 100 gigabytes. So 99 gigabytes is a whole gigabyte less. We didn't actually need to give it 1,024 more megabytes. The actual number is much smaller, more like 4 or 8, 4 megabytes per disk. So now we have a situation where we've wasted a little bit of space by rounding down too much to 99 gigabytes for our logical volume size. Not to worry, since we just created this logical volume, let's go ahead and remove it, and that'll show you the command for removing. To remove a logical volume, you just run LV remove, and we're going to specify my volume group / my volume. Now you can specify an absolute path to the device file if you'd like. Since we haven't talked about the absolute path yet, I'm just going to use this where we say group / volume. We'll just run LV remove, and it's going to ask us if we really want to remove that logical volume. I'll type Y to confirm, and logical volume successfully removed. Now I'm going to run the LV create command one more time, but this time we are going to use that lowercase l to specify the size in extents. However, we're not actually going to specify a number of extents. Instead, we're going to use a special parameter, which is 100% free. So 100% sign and all capitals free. You cannot use this value with the capital L. You can only use it with the lowercase l, but this is going to tell LVM to use 100% of the free space in this volume group to create this new logical volume, my volume. Now, if you already had one volume taking up some of the space on the volume group, 100% free would just give you whatever remaining space is in that volume group. We'll go ahead and run that. It's going to create, and if we come back over to gparted and refresh, you can see our second disk now is 100% full, just like the first one, because we used 100% of the available free space. So at this point, I keep coming over to gparted to show you what we're doing, but there are, of course, ways to confirm that your LVM commands are working the way you want them to over in the terminal, and we're going to take a look at some of those now. The first command I'm going to show you is pv display. This is going to display your physical volumes and some information about them. So you can see we have 2 physical volumes at this time. We've got dev SDC and SDD1. So it shows you the actual physical device. It shows you which volume group it's a part of, if it's part of a volume group. It's going to show you the physical volume's total size. As you can see, we've got 4 megabytes or 4 mebibytes unusable for our first disk, and then 2.98 mebibytes unusable for the second disk. So that's how much space is being used for the metadata in LVM. Like I said, the physical extent size is 4 mebibytes. Here we've got the total number of physical extents that we have, the total number that have been allocated to a volume. So that's all very good information to have. The next command I'm going to show you for gathering information is VG display, and this, as you might guess, is going to display information about our volume group, or groups if you have more than one. We only have a single volume group. It's the one that we just made. The format is LVM2. We've got 2 metadata areas, 1 on each disk. We've got the size of the volume group, so it's not quite 100 gigabytes like we said, it's 99.99. The physical extent size is the same as the extent size on our physical volumes. And the extent size, by the way, you can set that by passing in a -s with the VG create command. It's set by volume group. It's typically not recommended to change it. 4 megabytes is the standard default, and your physical extant size is not typically going to affect your actual disk performance. It might slightly affect performance for provisioning, so for running your LVM commands, but once everything is set up and you're actually using your disks, physical extant size won't really matter. So that's our volume group, and next up we've got LV display, and that's going to show us the logical volume, the top layer that we can actually interact with most directly. So here we've got our logical volume path. So this is one of the absolute paths that you can use to access your logical volume. There's another format as well that I'll show you in just a minute, but this is one of the ways that you can address the volume as a device. So instead of dev SDD1 for a partition, your volume here would be dev my volume group my volume. The LV display command breaks that down for us into the logical volume name and the volume group name. We do have a UUID for the logical volume. You can see we have read-write access to the logical volume. Size is just under 100 gigabytes once again. And we have a few other things listed here as well. Now this is a lot of information, and a lot of these numbers I'm kind of skipping over because we don't really need to know what they are to use our volume. And there are some ways to access a lot of this same information in a shorter format. That's going to be PV scan is the next shortest way to access information about your physical volumes. As you can see, this just displays a 1 line per disk listing of our physical volumes and then a summary. Similarly, we can do VG scan to get a listing of our volume groups. You can see it just says it found a volume group, my volume group. That's basically all it tells us. And finally, we can do LV scan to see our logical volume. We can see the size and we can see that it is active. And finally, the shortest way to access some information about all of this is using the PVS command. You can remember it as physical volume status or physical volume size. If we run that, you'll see it really is just telling us what the physical disk is, the volume group that it's part of, the format, and the size, which is just under 50 gigabytes per physical volume there. Once again, similarly, we can do VGS for volume group size and LVS for logical volume size. And you can see that last one displays a lot of headers, even though only the first few pieces of information are actually filled in. Those blank columns are used for things like RAID status when you're using RAID, and the columns that are displayed can actually be configured by passing in different options, which makes these 3 short commands especially useful for scripting. So that's how you can get information about the logical volumes that you're dealing with if you're sitting down at a system that is using LVM. So let's actually use this logical volume that we just created. Right now we can see that it sort of exists here, or we can see that it's taking up space on our physical disks, but we can't actually use the space without mounting it. And before we can mount it, we have to format it. Just like any physical partition, our logical volume needs to have a file system created on it to keep track of the information we're about to put onto it. So we're going to use the same command we would use to make a file system on a partition. We're just going to use an ext4 file system today. So we'll run makefs.ext4, and then we'll specify the path to that logical volume, which we saw was dev my volume group my volume. We're going to run that. It's just going to create a file system. Once again, just like it would do for a physical partition. I'm going to create a mount point for this volume at mount my mount point. Of course, you can call it whatever you want. And finally, we will mount dev my volume group my volume to mount / my mount point. So I'll run that, and the volume group is now mounted. To confirm that, we can run the mount command with no arguments, and we're just going to grep for my mount point. And when we run this, you'll see it actually tells us something a little bit different than what we typed in. We told it to mount dev my volume group my volume, but here it says that it's mounted dev mapper my volume group dash my volume. So this is the other way that you can address your logical volume as a file in the dev mapper directory. Now, either one of these options here are perfectly safe to use. They work the exact same way. If we do an ls-al on dev my volume group my volume, you'll see that isn't actually a file itself. That is a symlink pointing to DM0, which stands for device mapper 0, which is a file sitting in the dev directory. Similarly, if we do an ls-al on dev mapper my volume group dash my volume, it's pointing to the exact same place, dev DM0. So behind the scenes, there is no difference between using one of these naming conventions and the other. Now, why do they give you 2 different options? Well, dev my volume group my volume, this is a very easy hierarchy to remember because you've just got an entry inside of dev for your volume group, and then you can have multiple logical volumes in a single volume group if you wanted to. So this makes it easy to remember that your volume is quite literally inside of your volume group. It's a part of it. The reason why we have the option of using dev mapper instead is because there are some situations where if you name your volume group something strange, it could conflict with other files or just cause confusion. For instance, what if you created a volume group called SDA? SDA is the typical name that's given to the first SATA disk on a Linux system. So normally when you access dev SDA1 or just dev SDA, you're going to be accessing that disk or partition on that disk. But if you create a volume group called SDA, which nobody would really be there to stop you, you would end up with a file called dev SDA that's not actually a SATA drive. It's actually a volume group. And so if you've got actual SATA drives on the system, you could run into conflicting file names. And even if you don't have any SATA drives on the system, you then end up in a place where you might think that you do because you've got an entry in your dev directory called dev SDA or dev SDA1. Now, who would ever name a volume group that? I don't know. Since volume groups can be human readable and volume names can also be human readable, you typically want to give them a short, succinct, but human readable name. However, it's for that reason that we also get this option of using the dev mapper naming scheme. If you're looking at something inside of dev mapper, you know that you're looking at logical devices, not physical devices. And inside of dev mapper, it's still very easy to remember what the format is. It's just your volume group and then a hyphen and then the volume inside of it. So similarly to how you might have SDA1 and SDA2 for two partitions on a physical disk, you've got my volume group dash my volume, and then we could have my volume group dash my volume 2 if you wanted, after creating a second volume on your volume group. So that's just a note about the naming scheme. Now you might be wondering, Jacob, what about UUIDs? Why bother with this naming scheme at all and deciding which one to use when you could just use a UUID? Because that's what we typically recommend for physical partitions. Well, the problem with UUIDs on an LVM system is that because it's a logical volume, it can have things like snapshots or clones. And physical disks can have those too, but with LVM, it's a lot more natural to have those because they're features of LVM. So the problem with UUIDs is that they are actually the same between file systems on LVM snapshots. And for that reason, the fact that you can have conflicting or identical UUIDs much easier with LVM than you can with physical devices. When it comes to LVM, it's actually safer to use one of these names. The dev mapper name is probably the safest overall to use, once again, just in case you name your volume group something weird. But LVM is a more sophisticated system than just partition tables on a device, and LVM is going to use its metadata to keep track of the disks, and you can be confident that your LVM volume group and volume, their names are going to be read by the system and set up properly every time you boot up. You don't have to worry about them changing like you do with physical disks and their names. So now we have this thing mounted, we can see that it's mounted, and I'm actually going to open up another program. Now gparted here, it's really made to work with physical disks. So it's going to say, all right, you've got some physical disks, they're being used for LVM, and that's all that gparted is going to tell us. I am going to open up GNOME disks. This is another GUI program for managing partitions. You can see we've got our same hard drives, and you can see one of them is just an LVM physical volume. The second one has a partition that's an LVM physical volume, so it's showing us the same information as gparted. However, in the sidebar of GNOME disks, this is nice because it actually shows us the logical volume as well. So you can see it's detected as a 107 gigabyte ext4 file system, and the two disks instead of 50.0 like gparted says, gparted's using gigabytes like I said, whereas GNOME disks looks like it's actually using gigabytes. So slightly different units, and that's why the numbers are slightly different. But you can see we've got two 50 gigabyte disks making up one 100 gigabyte volume. So this would not be possible with physical partitions, but it is possible with LVM. And the system here, as far as it's concerned, if we open up any application and write to or read from our logical volume, the application does not have to worry about where that data is split between the two disks. LVM is handling that so that applications don't have to. So you can see that this is mounted at mount my mount point. I can click on that to open it up. And it's right here in Nautilus. It's a folder just like any other mount point. We've got 99.7 gigabytes free according to Nautilus. I am just going to give myself write permission to that directory really quickly. So I'll do chown jacob on mount my mount point. If I come back over here, now I can create a new folder. Instead of doing that, I'm just going to open up the videos directory. And here I've got a video. This is part 1 of my Extra Life 2020 live stream that I did. It's just an 11-hour video file. I'm just using this because it's a little bit large. It's 6.3 gigabytes. I wanted a substantial file. I didn't just want to use a text file. I wanted something that if it broke when we're about to do some other operations growing and shrinking on our LVM volume, we would know if it broke because the video would stop playing back successfully. So I'm just going to copy that to our logical volume. And that is finished copying. So you can see we've actually got a preview on it from our logical volume. Once again, I can open it up directly from the logical volume. I can scrub around in it, and you can see the entire video is working. This was me setting up an IRC server live on stream. 11 hours of pure gold, I tell you. Just look at me handling those config files. So we'll close that for now because we're going to, like I said, we're going to perform some operations on our logical volume here. I am just going to bookmark my mount point so we can get to it easily later, and I'll close that file browser. And by the way, back over here, we can now see in GNOME disks that our logical volume is 8% full. Once again, the physical drives, they're 100% full because they're being used for LVM. But we can keep track on a just volume basis for a logical volume of how full it is. Now let's say that I'm about to use this logical volume for a lot of video storage. This thing's going to turn into an archival volume, and 100 gigabytes is not going to cut it. I need a little bit more space. Well, with LVM, we can very easily add a physical disk and grow our logical volume using that physical disk. So we can essentially add space to the partition without being bound by a physical disk size. That's an advantage of using an LVM volume over a physical partition. So to do that, we're going to come over to our terminal once again, and I've got one more 50 gigabyte drive you might have seen in the dropdown here. This is just another drive identical to the other two. Like I said, the recommended way to add drives to LVM is to partition them. So I'm going to run gdisk dev SDE. I'm going to create a partition table. I'm going to create a new partition, and I'm going to set that to 8E00 for LVM. I'll write and confirm. And that's our partitioning done. I'm going to create a physical volume out of that partition by running pv create dev SDE1. And that's been successfully created. If I run, let's try PVS for physical volume size, you can see we now have a third physical volume listed. It's just not part of any volume group yet. And unlike our other two physical volumes, which have no free space because they're entirely allocated to our volume group, this third physical volume is not part of a volume group yet, so it has all of its space still free. Now to add it to our volume group, the command is very simple. I'm just going to type vg extend my volume group dev SDE1. And I do want to mention at this point, we can actually grow a logical volume live. We do not need to unmount. People can still be using the logical volume while we're growing it, which is pretty cool. When it comes time to shrink it, you do need to unmount because shrinking is a riskier operation. You need to make sure you're not cutting out any important file system data when you're shrinking. But when we're growing, it's pretty low risk, relatively speaking. So we can just do it here. So I'll hit enter. And you can see volume group, my volume group, has been successfully extended. So now that we've extended the volume group, if we run PVS, you can see that this disk is part of the volume group now, but we still have all 50 gigabytes free because it's not actually part of the logical volume. It's just in the group, it's there, it can be allocated, but we haven't allocated it yet. To extend the logical volume itself, we're going to run lv extend -l, and I'm going to use plus 100% free. So earlier, when we were creating our logical volume, we created it with the size of 100% free. At this point, we're setting the size to the current size plus 100% free. So this is saying grow as much as you can. Take up the rest of the free space in addition to the space you're currently taking up. If we just tried to run 100% free here, it would try to resize this down to the 50 gigabytes of free space, which would be getting smaller, not bigger. So we want to add that 50 gigabytes onto the existing space. So we'll start it with a plus there. And we're going to specify dev, my volume group, my volume. And you can see size of logical volume, my volume group / my volume changed from 99.99 gigabytes to just under 149.99 gigabytes. So we have now resized our logical volume. That's the equivalent of resizing a physical partition. Our logical volume has now grown. However, if we come back over to GNOME disks here, we've got something interesting going on. You can see that the size of our logical volume has grown to 161 gigabytes. However, we still only have 99 gigabytes free. And if we come back over to our terminal to take a look at that with df-h disk-free-human, you can see our file system at the bottom here is listed as my volume group, my volume, and the size for this is just 98 gigabytes. So the space has been added to our logical volume, but we can't actually use it yet. The reason is because we haven't resized the file system. The file system is actually a separate layer in the process than the volume itself. Just like when you resize a physical partition, you have to worry about resizing the file system to match. With LVM, when you resize your logical volume, you also have to resize your file system to match. So in order to resize the file system, for an ext4 file system, we're just going to run resize to fs dev my volume group my volume. Now if you're using xfs, then the command would be different. If you're using butterfs or any other file system, the command's going to differ. But for ext2, 3, and 4, resize2fs is the command that you can use. And if I just run that with no options, it's going to grow the file system to the available space. So I'll run that. And you can see the file system on dev my volume group my volume is now this many 4K blocks long. If we run df-h again, our size has now gone up to 148 gigabytes for the file system, and GNOME disks now recognizes that we have 152 gigabytes free of our 161 gigabyte volume. So that's nice. There is an easier way we could have done that. I showed it to you separated out just so that you can understand that the file system is separate from the logical volume. However, there is a flag we can pass into LVextend, and if the volume is using a file system that LVextend recognizes, it can actually perform that step for you. So we're going to back up, we're going to undo what we just did, we're going to shrink this file system and volume, then we're going to grow it again. Before we do that, let's just take a look. We never unmounted this mount point. This has been mounted the entire time, but you can see that our video is still here, still 6.3 gigabytes, and we can still scrub around in it. So the video is still working. So our data has not been corrupted as of this point in time. Now, the next part that we're going to do, shrinking the logical volume, if you're going to lose data, this would probably be when you're going to lose data. This is the part you need to be the most careful with because, like I said, when you're shrinking a volume and when you're actually removing a physical volume from a logical volume and a volume group, you are cutting space out, and you need to make sure none of your information is on that disk before you actually remove it. So the first step here is to unmount our logical volume. I'm not just doing this to be safe. It actually does require you to unmount the logical volume before you can shrink it. So I'm going to run umount on the path to our volume there. You could run umount on your mount point. That would work as well. And you can see that that has been unmounted over in GNOME disks. Next, we need to run a file system check. If you don't run the file system check, the file system resize will actually refuse to function. It will say you need to run a file system check first. So once again, not just doing this for fun, but doing it because it's required. So for an ext4 partition or an ext4 file system, we can run a check using e2fsck-f for force dev my volume group my volume. If you don't use -f, then it will basically look at a very small part of the file system and say, yep, it looks fine, no sign of corruption, and it won't actually check it all the way. We need to force it to actually perform a full check with all 5 passes. But you can see it was perfectly fine. It didn't find any problems. So now that we've done that, we can run resize to fs dev my volume group my volume, and we do need to specify this as the path to the logical volume. Now we can no longer use our mount point since we unmounted it. And now we pass in the new size that we want it to be. Now I'm going to use 99 gigabytes. If we used 100 gigabytes, it would still be too big to remove our third disk. And we can't just use 99.9 gigabytes or something to get us closer to the full amount of space that our 2 disks offer us because resize2fs does not take fractions. It doesn't take decimal values. If you wanted to get more precise than this, you could of course break it down into megabytes, and then you could go up very close to the full size of your first 2 disks. But I'm just going to round down to 99 gigabytes here. So I'm going to run that, and that's going to succeed. And next we need to run LV reduce. But before we can do that, we need to gather a little bit of information. LV reduce is going to have us tell it how much we want to reduce the size of the logical volume by. And we could just copy what we did up here, the amount that we shrank the file system by, but we want our logical volume to be as large as it possibly can be on those first two disks. And then if you want to, you can go back and grow the file system again to take up that little bit of extra space that you're missing with the file system. Now, to figure out exactly how much space to cut off of our logical volume, we're going to run PV display, and that's going to display information about our physical volumes. And we need the total physical extents for the disk that we're removing. Now, you can see the total physical extents is actually the same between these three disks, but we're about to remove dev SDE1 from the volume group. So I'm going to copy that number there of total PE, physical extents, on dev SDE1, and I'm going to run LV reduce -L, and I'm going to put a minus sign and then that number of extents. So dash lowercase l means we're specifying this in extents, and then we put the amount that we want to grow or shrink by. We know that we're shrinking because I specified a minus sign at the front there. And finally, we provide the path to the logical volume that we are resizing, which is dev my volume group my volume. I'm going to run that, and it's going to warn us, this may destroy your data, file system, etc. So this is your reminder that if you have not already resized your file system, you need to go and do that before you resize your disk. At this point, we have resized the file system. We know that the file system is actually smaller than this logical volume is going to end up, so we've got some buffer room. We should be safe, so I'll go ahead and hit Y to confirm here. And you can see size of logical volume changed from 149.99 to 99.99 gigabytes. So if we run PVS right now to display the size of our physical volumes, you can see the third volume now has 50 gigabytes free again because it's no longer being used in that logical volume. We also need to remove it from the volume group. So to do that, we're going to run VG reduce my volume group dev SDE1, and that's just going to remove that disk from the volume group. If we run PVS one more time, you can see that volume group is no longer listed. The physical volume is still listed here because the volume is still formatted as an LVM PV, but at this point we could go and repartition that disk with whatever other partition format we wanted to use, and it would disappear from this list. All right, and just to check our work here, let's go ahead and mount dev mapper my volume group dash my volume. So this time I'm using the dev mapper notation instead of the dev volume group volume notation, but we're going to mount it to the same mount point, my mount point, and I'll hit enter on that. We'll go ahead and open our file browser back up and navigate in there, and our video is still here, so that's a good sign. It's still 6.3 gigabytes, and we can still scrub around in it, so that's great. If you know anything about MP4 video, you know that if you're missing any data, the compression breaks down and you can't just scrub through the video like this. You'll have problems. So it looks like our data is still 100% intact, which is a good thing. Next, we are going to go ahead and grow that logical volume one more time. Like I said, I'll show you the slightly easier way to do it. So we're going to add that physical volume back to our volume group. So VG extend my volume group. We're going to extend it by adding dev SDE1 to the volume group. So take note at this point, over in GNOME disks, we have 98 gigabytes free out of 107 gigabytes. If we run a df-h, our total size currently is 97 gigabytes. So the command to extend your logical volume and resize the file system at the same time is almost exactly the same. It's lv extend -L. I'm going to show you one more special value you can use here. Last time I did plus 100% free, and like I said, that's going to take the current size and add all of the free space onto it. But instead of doing that, I'm going to say 100% VG. So when you specify -L and you don't put a plus or a minus, you're actually just specifying the exact size you want the logical volume to be. And since it's a lowercase l, it would be an extents, except we're using a special value here. So we want the size to equal 100% of the entire volume group. So not just the free space, we want the new size to be everything, which is going to be equal to the current size plus the free space. This is just another way you can write it out. So we'll specify dev my volume group my volume, and at the end here we're going to add an option -- resize fs. It's really that easy. If you add --resize fs, it might not work with all file system types, but with the common ones like ext4 and xfs, LVM can resize them for you. So we'll hit enter, and you see we get much the same output that we got before. It's going to resize the logical volume, and then it's just going to call the same command we ran before manually, but it's going to do it for you, resize to fs, and it says, okay, this is mounted, we are resizing online, and then it's going to say file system is now this many blocks long. So if we run df-h again, you can see the size has gone up from 97 gigabytes to 148 gigabytes. That is reflected over in GNOME disks as well. And if we go into our file manager one more time, the video is still there. We have not lost any data. We can still scrub around. So that is still valid. So that's great. And Nautilus, if we right click and click properties, it also recognizes that we have 144 gigabytes of free space, even though none of the disks on this system are this large. Once again, applications, they just see a single volume that's this big because LVM handles it all for you under the hood. All right, guys, so that's everything I wanted to talk about in this video. There is more that you can do with LVM. You can do RAID, snapshots, encryption. Some of that utilizes other tools. Some of it's built into LVM itself. And I will make more videos to talk about some of those more specific topics, but this was just meant to be an introduction to LVM. So if you've never used it, if you've never administered a system using LVM before, hopefully this was a decent introduction for you. It's really quite simple once you have that conceptual understanding of the physical volumes mapping to volume groups, and then the volume groups being dished out into logical volumes. That's really all there is to LVM itself, so I do hope that was helpful. If you found this video helpful and you want to help me make more videos, please go to nerdclub.knots.co and join the Nerd Club for just $3 a month. You support helping me get more equipment to make videos, helping me dedicate more time to make videos, and there are a few perks that you get as well just for joining. But for now, that's everything that I had to talk about today. So I'm Jacob Kaufman, I'm the Nerd of the Street, and I'll see you guys on the next one. Bye.